All right. These two graphs are very similar. R squared 49 cosine and R squared 49 sine. So again, when we looked at the kinds of graphs, these are both going to be, we said there's only one kind of graph that has an R squared, and this is going to be a lemniscate. So both of them are going to be lemniscates. And this is the cosine one. This is going to be the one that's going to be symmetrical about the polar axis. And then this is going to be the one that's going to be diagonal. Okay, so these both kind of go together. Now, to plug this in the calculator, I have R squared here and I only have an R here. So I have to take the plus or minus square root of both sides. In this case, 49 is a perfect square, but cosine is not a perfect square. I am not going to worry about simplifying it because when I plug it in the calculator, I'm just going to plug it in as is. I'm not, even when I do these problems, I don't ever even write this out. I just go to the calculator, I go to my R equals, and I type in the square root of 49 cosine of 2 theta, and then negative square root of 49 cosine of 2 theta. Now, we know from looking before that this is supposed to basically be a complete figure 8, okay? And there's not enough currently being graphed in order for it to actually complete the whole thing. If I go back under my window, right now I'm going from 0 to 3 pi. I'm going to go from 0 to 4 pi. And with these graphs, you don't have to go back under your window and change it. You know that it's going to all connect. You know that all the pieces are going to connect. That's enough to get you the whole thing. You can get the framework of these points and then you can graph it with 0 through 2 pi. That should be enough. But in this case with both of them, and just to show you that we wanted the whole thing, I went from 0 to 4 pi. So the difference here, if I go to my table, I'm going to have both of them, R1 and R2. This was my positive one. This was my negative one. I'm going to go to my positive one, my first one, my R1, and I'm going to plot as many of those points as I can, just to create a framework. So I have 0, 7. Pi 12ths is at 6.5. Pi 6 is at 4.9. Then I have an error. So I have an error, an error, an error. Pi halves, I still have an error. So from pi halves, I have 2 more errors. And then this 3.8 e to the negative 6 is at 0, okay? Then I've got, so this was 1, 2, this is at 0, this is back at 4.9, and then I'm at 6.5, and 7. If I keep going, 6.5, 4.9, error, error, error. You're starting to see this pattern here. There's my other pencil marks. There's that 5.9 e to the negative 6, 0. Then I'm at 4.9, 6.5, 7, and I can keep on going. Now, if I look at my R2, I went too far. At 0, it's at negative 7. Well, I already have that point. Then at pi 12ths, it's at negative 6.5, and then negative 4.9. And then I have so on and so forth. I got all of these points from just the positive one because I went out far enough. Okay. Now this should be enough. Oh, and I did these two. This is 6.5. There we go. That looks a little better. Now this is not going to cross inside of here, because if it were, there would have been another point. This one, there was an error. So it has to stay between those two. And these are all going to be nice and rounded. So if I change it to sine, and I graph it, graph looks very similar, and you'll notice, and it takes a while to graph all those points. Zero, 0. Pi 12ths is at 4.9, 6.5, 7, 6.5, 4.9, error, error, error. There's my 0 at pi again. Then I'm at 4.9, 6.5, it's going to be at 7, 6.5, and 4.9. This one ended up being a little bit easier to graph. Again, these are not going to cross either of those lines. It's going to come in between here and go through that point. It's going to come in between here, go through that point. Same thing here, and same thing here.